Test, test. Test, test. Just testing the sound. Okay, welcome everyone. We have 150 people, developer watching over X. Welcome, great to have you here. And welcome to this workshop. I will give the mic to my colleague Louis, who prepared a kick-ass workshop of, Louis, what will you present today?
Hi, everyone. I'm super happy to be here. Thank you, Valentin, to open this workshop. So we'll be talking about building reliable agents with safe capabilities. What do we mean by building reliable agent with safe capabilities? What is the problem first? So as we all know, or most probably know, LLMs are not deterministic. They are stochastic, which is just a fancy word to say kind of random. And they are a different paradigm for building software. because we're used to having deterministic outputs, which is not the case with agents and not the case with current AI. The problem with that is that we work in the crypto industry, and we cannot afford to have transactions being prepared randomly, right? If there is one character that changes, your funds are going to get lost. And so that's a big problem, right? Hallucinations. So we cannot really afford the uncertainty. And for that, there were a few solutions that were put in place in the past. One of the most widely successful was vectorization. So I'm not going to go super deep in the details here, but the idea was to give your data, give your model a bunch of docs, a bunch of data that comes from the application that you want this AI to be expert in. And this vectorization happened so that it can have context on what it's talking about. So yeah, one good idea was to feed your model after it's been trained with documentation from your product, for instance, or your GitHub repository, or the GitHub repository of competitors or projects that are similar, so it can have context. But the thing is, the truth is that it's still not efficient enough. We still have a lot of hallucinations, and even if your model is more aware of what it should be doing, it still hallucinates. So that's a big problem. And then we have also one big issue is money, right? Because experimenting with AI agents for now usually requires an API key for OpenAI or competitors. And even with the arrival of DeepSeek in the last weeks, it's still very expensive to experiment and iterate over your application. And so that can create a problem. And especially in the context of crypto, where computation is paid. We want to avoid spamming the blockchain, spamming the network. And so everything that's heavy in computation should be taken off chain. And so that creates also a sort of discrepancy between what you can do on chain and what you can do with AI agents, which are, as you may know, very resource intensive. And so for this reason, we have some people that have the opinion or the image that AI has nothing to do with crypto, with Web3, and to some extent that's fair. So the question now that we're trying to answer is, can we make agents 100 times more reliable when dealing with crypto transactions, right? And so one area that I would like to explore now, so as I said, you have like vectorization, you have system prompt and admin prompts that help you, guide your agent towards what you can do. But the best way is to, in my opinion, today is to basically take your agent hand and guide him through what has to be precisely done. And for that, we have what we call tools. So basically, widgets of code that your agent can call in order to enter a flow that is way more precise than what it would otherwise come up with. So these tools generally are very various. They can, search the web. They can make HTTP requests, create calls, perform mathematical computations, or anything that you want, as arbitrarily complex as you like. So this idea is that we now can use these tools to create, custom instructions on how to interact with the safe. And this is exactly what we'll be trying to do right now. So Today's agenda. So I've put 40 minutes, but like it can be a bit more, it can be a bit less. I have some time afterwards as well. So if you guys have some questions or any area that was not super clear, we'll have time to go through it after the presentation. This presentation will showcase three main things. The first one would be how to set up a local model for you to iterate on and start developing very quickly without having to pay the API cost every time you send a request. Then we're going to configure custom tools to read blockchain data reliably in order to really try to avoid all hallucination when fetching data from the blockchain and the internet in general. And lastly, we'll try to make the agent deploy a safe and send transactions because this is the end goal of what we're doing here, right? And then, as I said, we'll have some time for questions and answers right away. Does that sound good? If yes, let's dive in. So I just opened my code editor right here, and I just created a new directory. And so yeah, we're going to just so it's an empty directory, right? So we're going to first install a few dependencies. So we'll be using LangChain for this workshop. So you see a list here of dependencies, but don't freak out if you don't have the time to screenshot everything or record everything. First, because this workshop is recorded. Second, because this workshop is like the oral version of a tutorial that we just released that will help you do exactly what we're doing right now, step by step. So yeah, if you're feeling lost at some point, don't worry about that at all, and head towards the Save Docs, and you'll be able to find the tutorial. It's on the homepage, by the way, so you should be able to find it easily. Right, so we just installed a LangChain, LangGraph that I'll be talking about in a minute, Ollama, and the protocol kit, which is a safe TypeScript client to be able to interact with deployed contracts. And then we also installed TSX, VM, and Zod to run the script, be able to perform some blockchain-related operation with VM, and Zod, which will be used to specify the schema that we'll be using for interacting with our tool. Right, so we just created this, so you can see that we have a package.json created. We're going to go ahead and create a .env. So I'm going to fill that offline, obviously, because I don't want to leak all my API keys and everything. But I'll show you in just a minute what it looks like. Right, so I just did that, and now I'm just going to drag and drop this example here. So what did I just add? I just added a private key for my agent. So I basically just set up an account on MetaMask and exported the private key from this account. Added also the agent address, and then added a bunch of optional tools. So OpenAI, we'll see if we use it now, maybe at the end of the workshop to see the difference between the local model and OpenAI. And then a bunch of LangChain related variables that will be useful for debugging the agent and having a vision of what's going on under the hood, because it can be a bit troubling to understand what's going on in the agent's head, if it does have a head. Cool, so that's good. I think we can move on to choose our model. So to do that, I'm be using Ollama, which most of you already probably know. If you don't, you can go ahead and download this for macOS and Windows and Linux. So I've already done it. So I'm going to just show you how to download the model. So for this workshop, I'll be using Mistral Nemo because it's one of the most powerful models that my computer can run, and it's also pretty good at problem solving. So it's not just a chat bot or a chat agent, but it has some training so it can first interact with tools, which is not the case with all the models, and also do some reasoning, which will be interesting in just a minute. So I'm going to do Ollama pull Mistral Nemo. Fortunately, I did it already, so you guys won't have to wait for the download time. One thing you need to know is that model is 7.1 gigabytes, so you'll need that in the disk space, and you'll need around 16 gigabytes of VRAM or RAM if you're using a MacBook in order to run it. So, okay, we have our Ollama running. We have just downloaded Mistral. Let's just do a real quick test to see if everything is going right. And see if it's going well already. All right, so looks like, oh wow, now I'm talking Arabic. Very cool. Cool. So we just like that in 5 minutes, we just downloaded and are running our model locally. So there's absolutely no calls to OpenAI or whatsoever to Ollama or anything. It's running locally, and I find this pretty amazing already. So now that we have our environment set up, what I'm gonna do is create a new file that we will smartly call agent.ts. And I'm going to add a bit of code to it that I've already prepared offline. Here. So this is the main file of this workshop. We will have this main file and another folder that I'm going to create right now, so you guys are not confused. Sorry, it's a folder make dir tools. And so basically, yeah, the workshop, the code will be just that. These node modules, the agent code, and then some tools that we'll be building together. But what do we have here already? I'll just going to go through this file very quickly. So we have all the imports here. So you can see that LangChain allows us to import automatically the model. And I'll talk about LangChain just in a second. There is a bunch of lines that I commented because I'm keeping them for later. And then here we define the main model. So what we're gonna do in it, we're going to define a few tools, define our model. So here you see in a very simple way how we can just create the model using LangChain. And then we use LangGraph to create what they call a React agent. React, which is not for the JavaScript framework for building web apps, but for reasoning and act, which means that it's a set of tools that will help you create a flow with your agent, where it's not only you chatting with your agent, but your agent can actually have a chain of thoughts and have multiple iterations before they come back to you. So it's the concept of a chain of thought. I'm pretty sure most of you are already pretty familiar with it. But here we have this very simple tool that allow you to set it up very quickly. And then if you dive into LangGraph and LangChain documentation, you'll be able to edit this workflow. and have a very granular choice of what exactly you want your agent to do before coming back to you with his or her definite answer. So yeah, it's a super interesting workflow and tool. So I really encourage you guys to go take a look at LangChain and how it works, because it is really one of the most iconic agent framework so far. So you can see that in only just a few lines of code, we have everything set up, and we could already invoke our agent and start chatting. So this is how we're going to do this. So we have our agent.invoke, and then we can add some messages. So here we're adding just a human message because it's a very, fairly straightforward workshop. But you can of course add as well admin prompts, system prompts that will help you refine very precisely how your agent should be answering each question. And so we're just going to console log this. So we can probably try already. Let me check. Yeah, I think it should be working right now. So I'm just going to add one script that will help us start the bot more seamlessly. So what it does, basically just invoking TSX, giving it the end file that we gave it, and then just running the TypeScript file, right? So let's go ahead and do that. pnpm start. I'm kind of excited about this because you guys probably know already the demo effect, but when you're dealing with AI and the stochastic nature of it, it's even more wild. So I'm really curious what's going to happen. So yeah, we can see that. So sorry, maybe I'm going to come back and see. So the question we just asked the agent was, what is the current balance of the safe multisig at the address 0x22 blah 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 on chain ID 1? Please answer in ETH and its total value in USD. Here the test is kind of knowing how the model can be able to fetch data from its own weights, and can it read the blockchain data basically. And of course it can't right now. So what we have here, it says that it has ETH balance 10.06 ETH, and the total value in ESD would be $16,000, which is absolutely not the case. We can see that by clicking the link that it actually suggested. And we can see that this address has 4,000 ETH. So this is not really correct, right? But hey, that's the first try. We have absolutely no tool configured yet. So it's just basically the model taking a guess at how much money there is on this balance. And of course, you can see the problem here. So to fix this issue, we're going to add the tools. So I made one tool to fetch data from CoinGecko. So I'm going to touch tools/prices.ts. Oops. And I'm adding this function. So here we have basically an API call that will fetch the price on CoinGecko, do some very simple manipulation, and return this string, which is the price of 1 ETH is the price USD at today's prices. This is a very simple function. It could return only the price itself, but the thing is, you'll see that being as explicit as we can is going to be a big help for the agent, because if you just throw a number at the agent, it might not necessarily know what it is about, or know exactly, the exact context that why this number came up. And so providing precision, the price of 1 ETH is that amount at today's prices, will also give a way for the agent not to lose itself in its chain of thought. So that's basically just an API call, and then we have this object here, which is just a metadata that we're going to feed to LangChain, which provides a bit of context and as well as a schema for the input. Here we don't have any variables, so the schema is just empty. But the big the important part here will be the description, and same thing as with the return value. The description should be as verbose as possible, so the agent knows what this tool is about. Because one thing maybe I have not detailed yet is that it's going to be the agent's responsibility to choose which tools it wants to use, right? And so for it to understand at the best what it can do and what tools it should be calling, I really advise you to add the most precise description possible. So that's pretty much it with our price tool. So I'm just going to uncomment this here. Well, I'm just going to uncomment everything actually. Maybe not this one. Right. So now let's do the same with safe. Because yeah, this is cool to have the price of ETH, but our original query was to get the address of the balance in ETH of a given address. And for that, we're going to sorry, I think I copied and pasted the wrong code. So we're going to use Safe API for that, the transaction service. So basically, the transaction service is, for those who are not familiar with Safe, is part of the web infrastructure that we deployed to enable anyone to index their transactions so it can be sent back to the front end of Safe. So here we have one endpoint where we can check the balances of a given address. We have some data transformation to be able to read it. And same thing, we have the current balance of, we have a string as a return value, which is the current balance of the Safe multisig at address, blah, 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 is blah, blah, blah. And same thing, we have this metadata call to get the balance in ETH of a Safe multisig for a given address and a chain ID. So you see, it's not just like get the balance of an address, it's a bit more verbose, but again, that's to give clues to the model on how to or when to use that. All right. So we have that. I'm going to save those two for later. We have our tool here. And I think we're pretty ready to do another try. What do you guys think? Let me just check. Looks good. All right. So you know what? Let's try again to run the script. You will also notice that, of course, this model takes a bit of time to run. This is a simple MacBook Pro that I'm running these on. So yeah, the idea is to be able to do all these calls without paying money, because as a developer it can be a bit difficult to bear in mind that every try that you make you have to pay for them. So what do we have here? We have to calculate the total value in USD. You must multiply the balance with, okay. So we have the balance. We have 240,000 ETH, so we can see that it got the correct number. We have 664. That looks correct. Let me check that, but it looks good. Yeah, I have 659, so that's good. And it has 639 million for 443,600 USD, which seems pretty correct, guys. So I think we made it. Amazing. Let me check with the time where we're at. Okay, it's we're probably going to take a bit more time than 30 minutes, but I guess that's all right if you still bear with me. But yeah, that's a big win already. I'm pretty happy. So to sum up for now, we set up a local LLM that's running on our MacBook. We just read some blockchain data from it and made some basic calculation. I'm happy about this calculation because usually this model is off by an order of 1,000. And so I had this other tool here, Multiply, that's just basically to multiply two numbers together. When it's a bit lost, it helps to give the agent those hints. But yeah, I'm just going to add it real quick just in case, so that for the rest of the workshop, we don't have to worry about those. So here, touch tools / math, no, math singular.ts. And let's just add this. So you see here, very simple function. The result of A multiplied by B is 8 times B. Here the ZOD schema is two numbers, pretty straightforward. Call when you need to multiply two numbers together, pretty straightforward. And we'll see if the agent does that in a minute. Oops, multiply here. Okay, all good. So sounds like we are good to go. Now, the next challenge I would like to tackle would be, of course, to interact with Safe and be able to send transactions without, without being completely crazy about it, and give a bit more reliability to your agent. So let me just uncomment this, uncomment those, and go to the Safe tool here and uncomment the whole thing. All right. I need some imports here. Right. What do we have? Process name is. Oh yeah, I can do that, just so it does not complain anymore. All right. All right, so we're all good. Yes. So what did we just add? We just added this deploy new safe function, which will, as its name suggests, just deploy a safe. So we are using the safe protocol kit to do so. You can see that I am initializing the protocol kit with the agent private key to give it ability to spend transaction on my behalf. I took some time also to give some Sepolia ETH to this agent, so it can actually broadcast transactions. And then, yeah, we're going to create a new safe with the agent as an owner. This is an example, of course, and we have many guides and tutorials on docs.safe.global that will help you go a bit beyond those very simple setups. And so, yeah, we have for now our safe with one owner, a threshold of 1, and we add a random 10-digit integer so that we can run the script multiple times and it will just create a new safe each time. So yeah, now that we have initialized our protocol kit, we're going to get our safe address, create a deployment transaction, and then yeah, do a bunch of things so that basically it just deploys the safe when we call this tool. Yeah, and it will be waiting for transaction receipt. So theoretically, if everything works, the agent should be waiting for the transaction to be included in the block, to revert back to the user and give the address of the safe, the salt nonce that was used as well, in case you need to deploy the same safe, let's say on a different network, or if anything happens, you need to have this information because it's the last one that you don't have. And yeah, that's it basically. So yeah, it will return that with a nice link so we can try this right away. And then we have some metadata, same thing, with here the description to be called to deploy a new one-to-one safe multisig on Sepolia. I'm adding this so it does not add another question like, okay, provide me with a chain ID or create another discussion with the user. With this call or with this tool, it should be able to just deploy it. Right, so let's get back to our agent. We can see that we have the first chat here. One interesting thing is that it's a chat bot, right? It's an LLM, so we should be able to have discussions with it. Here we just invoke the message, like one message, and we get the answer. We console log the answer. Of course, in a production environment, you would be having this code running on an API, and the client sending the request to the API, and then this script running, and then sending back the response, right? But here, yeah, that was just an example to show that we can have multiple messages. Let's just uncomment this part. Just very simple prompt. Could you deploy a new safe multisig on Sepolia? And then we'll see what comes up with it. Oops. It should take a bit of time. So in the meantime, one thing I'm going to show you is the Langsmith platform, which is super interesting because this is where you'll get everything that happens under the hood. So I told you about this in the beginning of the workshop, and we set it up with the environment variables. And so basically, you can see here that there is one prompt that's currently running, and you can see the stack that it's calling. So you can see that the human asked, could you deploy a new safe multisig on Sepolia? And then you see all the steps on the graph flow that the agent is taking. So we can see that you have here a tool, deploy safe. So we can see that tool has been called. It's been running for 18 seconds, which looks good. And then you can see, the response of the tool. And so here you'll have the exact output of your tool, and you'll be able to see how the LLM takes it into account and produce a new response. So we can see that a new safe multisig was successfully deployed on Sepolia. Great. And it gives us a nonce and an address. Looks pretty good to me. So here, yeah. So here, oh, that's strange because or the agent triggered the call, triggered the tool. And we can see that it has some data, right? 0xday9600. So you can see that there is correct data in it. It's not making this up. It's not making the address up. But I'm still a bit disappointed because it should just return, the sentence that we gave it. The good part is that it still understood the instructions, and that if we go there and click, we should probably have a safe. And it's the case. You can see that we have a safe. Let's go to settings to see the address of my agent. This is the correct address. So yeah, we have an LLM just deploy a safe pretty reliably. I'm not really happy with the response prompt, but it just did that. You know what? Let's to make it sure, and let's just try again. And while I try again, I think we reached the end of the demo. So yeah, I think we covered pretty much everything. So what did we learn? So yeah, math is difficult, so I could not have the opportunity to show it, but usually, yeah, it's not great at doing very simple operations. Some models are better suited to do this than others. So please play around with different types of models, different types of prompt to see what works best. Of course, most of the time, the bigger, the better. Bigger models are like way more reliable. By the way, we could try, if we have some time, we could make a try with the OpenAI model to see with the same script what it outputs. And then we can see that the result is indeed very dependent on the user and system prompt. So I did not really play with the prompt to show you how it affects the output, but I can tell you that it is very, very significant. And maybe the last thing is that it's always an eerie experience to work with LLMs, and especially local LLMs, because you have really like this feeling of talking with the computer, which never failed to amaze me, especially when it starts to understand what you're saying and starts giving good answers. Yeah, I think that's pretty much it. I'm just going to conclude real quick, and then we'll be able to take some questions and see the latest outputs of the LLM. So yeah, I do believe that AI agents and AI in general are a paradigm shift in how we build software, how we interact with software. I do believe that the uh, interfaces that we'll be using will be changing a lot in the near future because of that. And that's true also, and especially with crypto, since, as you all may know, interacting with crypto, building apps with crypto, using apps with crypto is still so hard. So yeah, it can be really a breakthrough. We are determined at SAFE to accelerate the explosion of the AI agent economy, and you can count on us to help you guys on this endeavor. And maybe one thing to keep in mind, it's still very, very early. Those tools, LangChain, for instance, did not exist a couple of years ago. So yeah, we can explore together many more roads. One thing I did not talk about at all is output parsing, which is maybe one reason why the prompt was not really, oh, sorry, the agent answer was not exactly what I wanted. But output parsing is a feature by LangChain that can enable you to fine-tune the exact format and the exact structure or data structure that you want your LLM to answer you. So here it's answering with strings, but it could be, JSON. It can be any type of structured data. That's okay. And yeah, AI first UI. I'm very excited to see how it's going to work. Same thing with deployment. How you can deploy your LLM application. Those are fascinating topics, and we'll be writing more content on these in the near future. So yeah, stay tuned. Keep the docs.safe global open in a corner of your eyes to see in the next month the progress that we can make. And yeah, I wanted to thank every one of you for following this tutorial. You can find the written version of this tutorial here on this in this QR code. I've also prepared a feedback survey to help us understand if, this workshop was clear enough, hard enough, too easy, too hard, too technical, not enough. Let us know. I'll be super, super happy to have your feedback on that. And yeah, happy coding, happy hacking, everyone. Thanks a lot.
Yeah, thank you so much, Louis. And I hope you guys enjoyed this. I really liked what Louis has been preparing here. And I think the deterministic setup with LangChain is very promising. So we have some room for questions. We have the stream set up. So if you're listening from X, what most people do, please just like write a comment in our message channel. If you don't find it, you can also just like ping save, and you can also go to YouTube and write it in the comment section. We'll wait for 1 more minute if we have some questions, and otherwise, please fill out the survey. Maybe Louis, if you can bring back the slide with the QR code again.
Yes.
This would be super helpful for us, yeah, to cater the best content to you guys. Yeah, we just wait 1 more minute if there are any questions. You can also tag me or save. Yeah, I don't see questions popping up. Otherwise, feel free to answer now in the last minute. As Louis said, this will be a tutorial. I think it's not released yet, but we'll try to release it this evening, this night.
Oh, it is. It is.
It's
It is.
already released. Easy. Perfect. So yeah, you can watch it, rewatch it, or go on the tutorial page. Yeah, and if there are no further questions, I think we can close the stream, right?
Cool. All right. Well, thanks again, everyone.
Thanks again and have a good day. Ciao. Thank you, Louis.
Yeah.